Thermochemistry video number 2, we go to definition for enthalpy. Number 1, enthalpy of formations, the heat change when one mole of compound is formed. When it said heat change, it can be endothermic and also it can be exothermic. When one mole of compound is formed, when we make the equation for enthalpy formation, we need to let the product 1 mole. For an example, formation of ammonia NH3 it's come from elements nitrogen form of gas and also hydrogen in form of gas. So when we need to let NH3 1 mole, so stoichiometric coefficient for nitrogen gas be 1/2, hydrogen gas 3/2. So enthalpy formation of ammonia negative 46.1 kilojoule per mole. Next example is enthalpy of combustion. The heat released when one mole of substance is burned completely in excess oxygen. So heat release means the enthalpy of combustion is always exothermic. Okay, when one mole of substance is burned completely in excess oxygen. So when we write the equations, we need to let substance that burn, in this case methane, always 1 mole. Next is enthalpy of atomization. The heat absorbed when one mole of gaseous atom is formed from its element in its most stable state. The heat absorbed means enthalpy of atomization is always endothermic. When one mole of gaseous atom is formed from its element, so refer to the products. So in this case, let's say we have sodium initially in form of solid. After undergo atomization process, it become sodium in form of gas. Another example, we have chlorine initially in form of gas, diatomic molecule, and after atomization process it become single atom. So if we refer to definition, we need to let gaseous atom that form always 1 mole. So next is enthalpy of neutralization. The heat released when one mole of water is formed from the neutralization of acid and base. So the term heat release refer to the neutralization means always exothermic. So neutralization always release heat. So when one mole of water is formed from the reaction of acid and base, so we need to find out when we write the equations, H2O always 1 mole. So this is how we write the equation for enthalpy of neutralizations. So next is enthalpy of hydrations. The heat released when one mole of gaseous ion is hydrated in water. So heat release, it is understood the hydration process is always exothermic. So when one mole of gaseous ion is hydrated in water, so when we write to the equation for hydration process, the reactant should be in ion, the condition in form of gas. So after hydrated process, it become aqueous. So another example, we have chloride in form of gas. Okay, after the hydration process, it form aqueous. So 1 mole is always referred to the reactant, 1 mole. So this is how we write hydration equations. So this is enthalpy of solution. The heat change when one mole substance is dissolved in water to form very dilute solution. So the term heat change means The enthalpy of solution can be endothermic and also it can be exothermic. It can absorb heat, it can release heat. When 1 mole is substance, so the substance in this case, for example, KCl in form of solid, dissolve in water and will finally form aqueous solution. Aqueous solution. Initially in form of solid and will form aqueous solution. This is how we write the enthalpy of solution.